So you already heard the spiel about me, so this is just for reference. The one thing that Bob didn't mention is I'm on the Off Heap. I'm actually the crotchety old guy on the Off Heap podcast. So if you listen to me, I'm the opinionated guy.
But he's usually right, so.
With regards to taking notes and what to pay attention to tonight, don't worry about it. The deck, the code, it's already up on GitHub. I pushed it up today, as well as this is being videotaped. So if anything, please ask questions. If you have questions, ask them. I would much rather have a dialogue with you guys than talk at you for however long this takes. Can I get a quick lay of the land with regards to who knows and is comfortable with what? Quick show of hands. Who here is comfortable with Spring? That's good. Keep them up, keep them up, keep them up. Spring integration? Spring batch? Spring XD? Okay, I kind of expected that. Spring Cloud Stream? Spring Cloud Task? Spring Cloud DataFlow? Okay, that's kind of what I expected. Okay.
OCI slide next.
So what are we going to talk about tonight? This talk is really about data integration. It's about building integration applications. It's about moving data around. It's about ingesting it. It's about transforming it. And those types of applications over the past few years have gone through a bit of an evolution. When we think about how we would have developed those type of applications as recently as 3 or 4 years ago, we probably aren't developing them the same way as we are today. 3 or 4 years ago, you probably would have, hope the screen stayed up. 3 or 4 years ago, you probably would have built it as a monolith. Okay, so you probably would have developed an application maybe with many integration flows, many batch jobs, all packaged together in one complex artifact. Maybe deployed it on an app server of some kind. The problem with that, though, is those artifacts are typically difficult to test. The more complex an application is, the harder it is to test. And so getting those things, even small changes from your laptop into production, become very complex. Going through testing, going through change control. The bigger the artifact, the more complex things are, the harder it is to get through that process. Since then, you've seen this big spouting of big data platforms. This is basically a logo soup of the current state of things. These platforms are really good with big volumes of data. Okay. Small volumes of data, not so much. And then the question is, what is big data, right? Big data for me might not be big data for you, might not be big data for you. Yeah. Sorry. Yeah. Okay. Yeah. Okay. Can you hear me in the back? Is that better? Yeah. Okay. For example, who here thinks 10 terabytes is a large amount of data? Okay. Do you guys realize what Hadoop was developed to do? Yeah, it indexed the internet, the whole thing. So the idea of these big data platforms being used for a handful of terabytes, basically that's stuff you can fit on a hard drive that you can buy at Best Buy these days. Those types of platforms also have large learning curves. Okay? If I want to pick up Scoop, let's say, I have to start from scratch. I'm going to learn this new technology. And it's not like anything else I've done in any of my other enterprise development. So I'm really coming in as a newbie on these new technologies. And then after I've mastered Scoop, now I need to learn Spark, right? Because that's the new latest and greatest thing. There's almost nothing in common between the two. So there's this, I've climbed Mount Everest only to see the next mountain, and the next mountain, and the next mountain. As you learn these, you also realize that there's a heavy footprint in your code. If you've ever looked at, let's say, a Spark application, there's no debating, it's a Spark app. There's no question about what that code is actually doing, because that API is embedded throughout your code. It's not an example of creating POJOs with a couple annotations sprinkled in and things happen. You develop a Spark app, you develop a Scoop service, and so forth. Because of all these things, again, they're hard to test. They have complex environments with lots of moving pieces. They're hard just functionally to test. You need people that are technically sound to test these things. And again, because of these problems, it's hard to get from the laptop to production. So that time that your competitors are getting functionality in quickly, those .coms guys working in garages, they're getting that functionality from a laptop to the cloud a lot faster because they don't have all that overhead. I want to be clear, though, on this particular category. It does have use. There are use cases where this does make sense. So I don't want to discount this completely. Okay? But just be aware that this particular category of applications, if you think of the Gartner hype curve, we're definitely past the hump. And people are starting to, these technologies are starting to come back to earth. They're not going to solve everything. Which brings us to data microservices. These are applications that are built in a cloud-native manner. So they're doing all of the 12-factor patterns that you should know by now. So external configuration, small scopes, domain-driven design, all those types of things are these apps encompass that. They're developed and tested in isolation. So instead of having this monstrous application that I need to move through these environments, I'm going to have very specific, very small pieces of functionality built into each individual application. That allows me to independently scale them. So instead of scaling a monolith, which ends up taking a lot more resources than it probably does, or trying to scale to a Hadoop type scale where you literally need a data center's worth of hardware to run, you can independently scale only the pieces that you care about, only the bottlenecks that your system needs scaled to. The development model for data microservices is typically a familiar model. If you've developed other microservices or other services in general, the APIs you use for these are probably going to be familiar. If you guys missed the first slide, this is a Spring talk. You're probably using Spring in your web apps, maybe integration apps, maybe your batch apps. All that knowledge that you've gained over years of Spring development, you can translate and use in these other applications. They're small and simple to test. I have a microservice that does one small thing. Let's say it's an HTTP source. All it does is it accepts HTTP incoming traffic and writes it to a queue of some kind. That's a really easy app to test. And because of that, they're operationally easy to govern. QA becomes really easy because I can swap out those little pieces individually and have them QA just that one piece. Change control when you have to worry about auditability and such, that becomes a lot less impactful because now instead of swapping out an entire flow or an entire collection of flows, you only need to swap out one small piece. It's like letting your minions out into the world to do your bidding. There are two main processing models with data microservices: streams and tasks. We'll talk about both tonight. The last step in the evolution is really data integration as a service. This is where we talk about, instead of developing microservices or concentrating at the microservice level, now we're talking about composing microservices into streams and flows. So now instead of being worried about an HTTP source or a transformer X, now I'm thinking about the Twitter ingestion stream. I'm thinking about the statement generation flow for task processing. We're talking about a level up higher. As I mentioned, the streams and flows become your app. So while you develop microservices, the actual business functionality doesn't come from the individual microservices. They come from the aggregation of those microservices into a more meaningful thing. These platforms typically offer orchestration and operational coverage. So are my apps still running? How do I hook my apps together? All those types of things. That's what this level of platform provides. Does that make sense? Which is where Spring comes in. If we think about Spring in the portfolio, you can start off with Spring as kind of the base foundation for everything, right? We've got the Spring Framework, Spring Security, Reactor. Those are kind of the foundational layer of any Spring project. On top of that, we layer on things like Spring Integration, Spring Batch, workflow-specific, workload-specific frameworks. The frameworks I'm going to be talking about tonight layer on top of those. So Spring Cloud Stream is really a layer on top of Spring Integration. Spring Cloud Task, while not technically a layer on top of Spring Batch, is heavily influenced by the design historically. And if you are familiar with Spring Batch, it should be a really, really simple ramp up. There is also integration pieces both this way and this way. So Stream integrates with integration, obviously. Stream also integrates with Task and vice versa. And Task also integrates with Batch. Let's start off with Spring Cloud Stream. It's a framework for developing message-driven microservices. If we take a look at this, let's say this is a stream flow. So I've got a time source, a transformer that's going to change something, and then a log is the sink. This may be something that you're familiar with seeing in Spring Integration. You'd connect these with channels of some kind, the transformer, source, and sink. So these are common integration pattern concepts. What Spring Cloud Stream does is it abstracts the arrows for you. So now instead of you managing the connections between them, instead of you managing the middleware in between them, we handle that for you. So basically what we do is we have a binder implementation. The binder is either, the ones we support right now are either Rabbit, Rabbit, Kafka, or Gemfire. And all you do is you add in, you define your microservice, you say if it's a source, a processor, or a sink, and then you say what binder you want to use. Am I talking via Kafka? Am I talking via Rabbit? Am I talking via Gemfire? Do I have another middleware that I want to implement my own binder for? But the actual connection factory, the templates, all that type of stuff, all that's behind the scenes now. All that stuff is taken care of for you. This is the magic bit of code within Spring. When you develop your application, you'll use this annotation, enable binding. And then you'll pass it the type of microservice you're developing. Are you doing a source? Are you doing a processor? Or are you doing a sink? A source defines a channel called output. A processor defines a channel called input and a channel called output. And I'm sure you guys can figure out a sink defines a channel called input. That's all you need to worry about within your application. The rest is taken care of for you. It's important to realize that this is, while the framework is new, it's sitting on top of Spring Integration. Spring Integration and Spring in general have both been around for over 10 years. I can't think of many other frameworks that have been around for that long in as many enterprises as Spring is as battle-tested as this framework is than Spring. Because of that, even though it's really just a thin layer on top of Spring Integration, you can go in knowing that the stuff is going to work. It's not a framework that we've been banging on for 6 months, brand new, greenfield, going to push it out, and it's like, OK, now you guys can test it for us. That's not what we're doing here. In fact, we already have users of Spring Cloud Stream. I don't know about Task, but in DataFlow. We've got 3 clients in production and a handful doing POCs and et cetera. So some use cases for Spring Cloud Stream. Data ingestion is probably the obvious one. So I want to bring data in, whether it be into a big data system, whether it be into my database, just the ingestion of data in general. Data transformation. I need to move data around. I need to transform it from one format to another. I need to do some type of processing on it. Real-time data processing. So think of any of the integration use cases you can think of that are message-driven. So things that you want to be able to react to things real-time. Finally, IoT. So streaming sensor data from wherever, reacting to that data as it comes in real-time. All of these are common use cases for streams. Let's take a look at Spring Cloud Stream in action.
Hey, Michael, while you're setting that up,
Shoot.
can you speak to what are your requirements when you say real-time? What's kind of the expectation around that? Because real-time means different things to different folks.
Traditional middleware, yeah.
So millisecond, like
Whatever your middleware will support. So like, there's obviously a large difference between Rabbit versus, which is one type versus Gemfire, which is an in-memory data grid, versus Kafka, which is the file-based thing. So it's really a function of your middleware more than it is of our code. So I already have Rabbit and Redis running. We don't need Redis right now, but we will use Rabbit. Let's go over here. So I'm just going to do a very simple time pipe log application. We'll look at code in just a second. Right now I just want to demonstrate how this works. So all I'm doing is I'm running a Spring Boot Java application. It's just a Spring Boot fat jar is all I'm running. So in this case, this is a time source. It's the Rabbit implementation specifically. And I'm passing in a single parameter. Spring Cloud Stream Binding Output Destination. This is the name of the channel that I'm going to use to connect my two microservices. So I'm going to have a time microservice, and I'm going to have a log microservice. Time is going to write out to the TikTok channel, or in this case, TikTok queue on Rabbit. And then the log microservice is going to listen on the TikTok channel or queue for the response and write it out. So if we go ahead and run that guy. That's running. No, same thing. I only had one additional parameter here, which is the port for Tomcat. That's just so I don't have port conflicts. And so as you can see, I've got two JVM processes. I've got the time source is kicking out the current time once a second, and log is actually logging it once a second. Does that make sense from a functionality perspective? OK. So I'll go ahead and kill those guys. Let's go ahead and actually look at some code. So what we're going to do is we're actually going to apply a transformer in between them. OK? The idea being that it's 5 o'clock somewhere, and which is really all we care about. So I wrote a little transformer here that is going to literally change whatever the time is to it's 5 o'clock somewhere. The tons of Java code that this transformer requires is, if you've written a Spring Boot application, this should be familiar. This is basically the bootstrapping piece of a Spring Boot application. So I've got my main method, Spring application.run. Just passing it in the class. It'll do component scanning for me to find my configuration, which is here. My configuration starts off with that configuration, basically telling Spring, hey, this is a configuration file. Enable binding. So this is that annotation, that magical annotation I mentioned in the deck. So enable binding processor. So I'm identifying this as a processor. Then I have this simple method. I've got the @transformer annotation on it. This is the regular Spring integration transformer annotation. It takes two parameters, an input channel and an output channel. The input channel is processor.input, and the output channel is processor.output. That's how we wire in those pieces. Then I've got a simple transform method. It takes in a string for input. That's what the time source is providing. I'm going to log it just so we can see that the time is changing and I'm not really screwing with you guys. And then I'm just going to return it's 5 o'clock somewhere. So when I run this in the middle of my other two microservices, I should see really nothing in the time one. I'll see logging of the time in the processor's logs. And then in my log one, I should see it's 5 o'clock somewhere over and over. Does that make sense? All right, so go ahead and start my time. Oh, wait, hold on. Source. So again, this is the time source, although I'm calling it 5 o'clock input for the channel between my source and my processor. that'll start up. Oops. Now I'll run my processor. So my processor, I actually have to define 2 channels. I've got to define stream bindings input destination, 5 o'clock input. But I also need to find stream bindings output destination, 5 o'clock output. So I've got 1 channel in between the first 2 microservices, 1 channel between the other 2 microservices. Does that make sense? So that'll be the processor. And then here's the sink. We can already see in the processor, I'm getting that input from the time source. And then once this guy's done booting up, it's 5 o'clock somewhere, which is really all we care about. Does that make sense? Yeah. Where's the input coming from? Yeah. It's coming from the time source. So I actually have 3 Java processes running here. This one is the time source.
Right. I just want to see the annotation.
Oh, it's so the source and the sink are ones that are out of the box ones. Give me a second. Let me see if I can find my project with it. Oops, this one. Sorry, give me a sec to open up this one. And then, so time is, oh yeah, time. So you can see, this is the time one. This is the one that's out of the box, but that's, so enable binding source for the time one. Does that make sense? And then actually,
So if I have 2 microservices, how are you going to bring this in? Changing those other 2 microservices to work with this processor? And is that the eventual goal?
sorry, what was it?
What's the goal? So you have 2 microservices, we're putting this processor in and do some type of data information?
Yep,
Or-
yep.
Okay.
Data transformation, validation, fork join. You can do a number of different options with that. This is just obviously a very simple transformer example, but anything you would do in the middle of a flow between the source and the sink is valid for a processor.
All right, but it's minimal change though, I just basically have to configure this up on both of those endpoints.
Yeah, the only changes you need to make, you don't impact anything on the source or the sink side, and the only thing you need to change is where you're pointing the 2 microservices so that all the dots are connected, which we'll get to an easier way to do that in a bit. Yeah. Correct, yeah. Excellent question. Yeah, so the question was, how do I differentiate between queue versus topic? By default, everything within Spring Cloud Stream is a topic. We allow that so that you can hang multiple, basically you can do the fork join concept really easily. And there really isn't any type of performance impact with that type of stuff. You can, via configuration, switch it to a queue if you know specifically that that's what you want. But in most cases, the topic works, so that's, like I said, by default, they're all topics.
So as the developer, am I on the burden of configuring the queue part, the valid queue part? Or somebody else will set it up and the developer...
Can you repeat the question, too?
I will.
So the framework will just provide me with the API and the configuration part of the messaging system. Who's doing that?
So the question is, who's configuring the messaging system? And it depends on what you mean by configuring the messaging system. If you mean who's creating the queues, we are. We can create them. We create them for you. You can obviously, you don't have to let us do it. You can configure them in advance if you want. But yeah, I mean, if I go into Rabbit right now, I'll have a few extra ones because I haven't done any cleanup. But you can see these are the 2 queues that are in use. They weren't there before. I mean, the applications are what creates them. Hold on, there was one up here first.
There's no particular reason this has to be 3 independent JVMs, right?
Versus
Put them all in one.
so we don't have an in-process binder. So if you want to use Spring Cloud Streams, it's expected that you're going to use an external middleware for the binding piece.
It could go from the JVM outside of the back end, right? Theoretically. Like if you have one process that sends messages to a queue and then another process.
So could you have your source processor and sync all within the same JVM, and it's just hitting back out to the middleware?
Yeah.
That sounds.
Yes, it does.
Yeah. Theoretically, I honestly don't know. Practically, don't do that. Hold on. Next.
Do you have test cases to show us what the right unit test integration test is? You mentioned that it should be easy in the browser.
Excellent question. So the question was, do I have unit tests to show you? I do not, because this is demo code. However, I can point you to a framework that actually does contract-based testing, and it does have Spring Cloud Stream integration. It's called AccuRest. We're actually in the process of taking it in. It's going to become Spring Cloud Contracts, I think. But that's available on GitHub right now. Check it out. It's maintained by one of the Spring committers.
So with that framework, would be easier to test the whole workflow?
Yes. Yep.
Right?
Yep. What do you want?
So quick question. So this is a straight direct communication, right?
Mm-hmm.
So what about more complex cases like the fan out case? Or, how would you implement something like that using Spring DataFlow?
So the question was, how do you? So this is obviously very point to point. How do you implement more complex things? So there is a laundry list of additional functionality that, based on time, we could be here till 2 a.m. tomorrow morning. If I went through every little piece of it, we're not going to get to tonight. One of the things is things like name channels. So I can, I didn't use name channels in this, but by using name channels, I could then hang as many processors off as I want, not counting the scaling aspect, like just doing multiple modules, but literally having like wiretapping and those types of concepts. I'll actually demo wiretap in a bit. It's a little more complex, but I'll use DataFlow to actually orchestrate that. Yeah.
Would it be wise to say that Spring Cloud Task is a stripped down version of Spring Batch?
We'll get to Spring Cloud Task in just a minute. That's actually next.
How do you introduce monitoring into this solution?
So how do we introduce monitoring? Let's hold off on that till the end and let me know if your question has been answered. Is that fair? Yeah. Okay. Anything else? Going once? Yeah.
Can you do the same kind of like stream management on Kafka that you're doing on like Rabbit? Can it like create topics?
Yep. It's the exact. So the code is identical. The only difference is your dependencies change. That's really it.
That's impressive.
In fact, on large volume systems, we recommend Kafka. And in fact, it's actually the default.
Do you have any type of failover for this?
Failover meaning?
One of the microservices goes down.
So that's really good question. Let me talk about that with the DataFlow piece of it. Anything else? Yeah.
Did the that this will face out XT?
Also excellent question. Hold on to that thought. I think we're getting down to the hold on to that thought group of questions, so let me just keep going, okay? So let me go ahead and kill all these guys. So Spring Cloud Task. This is kind of the other processing model within data microservices. When we think about microservices, we think about REST endpoints, even these message-driven ones. We think about, as you brought up, failover, right? If it goes down, it's a bad thing. There are use cases, though, where a process ending doesn't mean it failed. It means it's done. And that's what Spring Cloud Task is intended to do. It's a framework around building microservices that have an expected ending. Some features that Spring Cloud Task provide. Number one, a task repository. If you're familiar with Spring Batch and the batch repository, it's a lightweight ripoff. It's basically the same thing. just not as much data is stored there. Spring Batch integration. So in a number of different ways. The ability to associate a task with a batch execution. We also have the ability to, within Spring Cloud Task, we add listeners, if you want them to, that will emit batch events. So the start of a step, the start of a job, reading, processing, writing, skips, all those types of things. By just adding the enable task annotation and having the right dependencies on your class path, will automatically emit all those messages for you if you want. Obviously, they're configurable to turn off if you don't want them. The other piece of batch integration we have is there's a new partition handler. Traditionally, when you're partitioning batch jobs, you've had two options. Option one is in JVM thread-based, and external JVM using message channels. Now there's a new one called the deployer partition handler. What this does is it will actually launch your workers as tasks. So if you run your batch job as a task, you can run your workers as tasks as well. So when the step executes, it'll actually launch the workers, they'll run, and then they'll shut back down. So that elasticity that people have been asking for years about partitioning batch jobs, this partition handler accomplishes that. Stream integration as well. So obviously, if we're generating events, we need to send them somewhere. And we do that via Spring Cloud Stream. So not only the Spring Batch events, but also the Spring Cloud Task events are also sent via Spring Cloud Streams, as well as the ability to launch tasks from streams. So if I have, let's say I've got a source that is pulling an FTP directory. When a file comes down, I want to launch a batch job to ingest it. I can have a FTP source send a message to a transformer that transforms it into the appropriate message. And then with one annotation, we provide a sync called the task launching sync that will launch a task based on the request that it gets in. All you need for all that beautiful magic is that. Add that annotation with the right dependencies, and all that other stuff you get for free. Somebody mentioned if this is replacing XD, all those eventing type things that I just mentioned, you got those for free with the Spring XD containers. Now you don't need the containers. Everything is boot apps. So by using Spring Cloud Task, we rolled all that functionality into this. Just like I mentioned before with streams, again, it's built on Spring. So all this stuff isn't greenfield, new concept stuff. This is all stuff that has been in production and has been battle tested for many, many years. Some use cases for Spring Cloud Task. Running batch jobs. The batch integration pieces alone provide some great usefulness to your batch jobs. One-off processes. If you use automated database migration tools, like Liquibase or whatever other options are out these days, running those is another great option for this. ETL processes, so moving data around, transforming it, all those types of things. Specifically things where there's a finite amount of data. Because with a finite amount of data, you expect that ending, which is where the Spring Cloud Task really makes sense. Finally, data science. The idea of doing offline processing to generate data models that are used later in streaming processing is a common paradigm within data science. So you get a large amount of data, you need to train a model so that it understands the data so it can predict things in the future. That training piece is the computationally complex part. That's the heavy lifting. And so that's typically done out of band, or in this case, you would do it just via task, and then that model is injected back into a stream for evaluation. Let's look at a task. Oops. All right, so let me just really quickly check my database. Come on. Okay. So I'll show you the code for this one before I run it because it's mind-numbingly simple. So just like the stream microservice, on the task side, we start off with the same boot shell code that every boot application knows and loves. And then my configuration looks like this. So I have configuration at enable task. And then a task is the boundaries of a task. So what are we actually tracking here is the execution of any of the command line runners or application runners within a boot application. So Spring Boot, if you have a command line runner or application runner on startup, will automatically run those methods. So we record the start of it and the end of it, including any errors that happened along the way. So I've got a simple command line runner. I just wrote it in line. And all I'm going to do is I'm going to do a system.out.println. You could have whatever. You could have a batch job in here. You could have data science algorithms in there. You could have a system.out.println like I can. So it's as simple or as complex as you want it to be. That's it for a task, though. The only additional thing I did is in my configuration, I have configured a database just so it knows where to talk to. So if we go ahead and run that. Oops. Oh, hello. Oh, I got the wrong thing. OK, I'll start off with the error condition since that's the one that I actually have compiled right now. Sorry.
Ouch. Oh, God.
Oops. You know what I want? Just do it. There we go. OK, so by running that, it created a collection of tables. You saw me drop and recreate it just a second ago. But it created these tables out of the box. So task execution, task execution params, task sequence, because I'm on MySQL, and MySQL doesn't support sequences. And then task batch, which is only used when you're using batch, the batch integration. So if we look at task execution, these are the columns. So you've got a task execution ID, a start time, an end time, a task name, an exit code, an exit message, and last update. So these are the things we're going to track for you on any given Spring Cloud task. So when you run your tasks overnight, you get in the morning, did it run? Did it run right? I'm like, OK, my pager didn't go off. Now you can actually just check in the database and everything's fine. So if we go ahead and actually look at what happened with that error scenario, you can see I've got the ID is 1. I've got my start and end time, my application name, so that's the name of my task. The JVM returned an exit code of 1. Spring Boot allows you to map that if you want. And then because it errored out, I actually have the full stack trace here ready for me in the morning. So I know that that's what happened. So I can fix it. Is my code right now? So my code's right now. I can actually rebuild this and run this again. And this time it should work. Oh yeah, nope. Any test-driven developers? Yeah.
again.
I told you this talk gets better with more. There is an actual framework reason for that that I can get to if you guys really want. So now I'll go ahead and run this again. This time it should succeed because the code's actually should work. And so that worked. So you can see I've got debug logging turned on, so you can even see in the logs creating the task execution, its ID, all that information. That's the creating. Here's my system.out, and here's the updating afterwards. And then if we go back to MySQL, you can see this time it returns 0 with null as the exit message because nothing happened. Does that make sense? So I've done a lot of stuff at the command line tonight. I've had to specify properties for channels to talk to each other. I've had to do a lot of things myself that if anybody who's tried to do this type of stuff in production knows, the more keystrokes it takes, the more likely you are to screw it up. So because of that, there's Spring Cloud DataFlow. To answer your question, Spring Cloud DataFlow is really Spring XD 2.0. It is the evolution of Spring Cloud DataFlow, or Spring XD, from a container-based solution to a more cloud-native architecture. The reason for that is because, so for those of you who are unfamiliar with Spring XD had an admin container, and then instead of running boot applications, you ran containers, and inside the containers you deployed Spring contexts that were in a custom format and all these different things. The thing though is we found out that a lot of the features we were baking into the containers, like a failover, whoever asked it earlier, and all those resiliency requirements, nowadays there are plenty of platforms that do that. So we can either continue down that road and try to compete with them, which doesn't make any sense, or we can embrace that and actually just expect to run on. And that's what we've done. The whole goal of Spring Cloud DataFlow is to take advantage of those modern application platforms. Specifically, Cloud Foundry, Kubernetes, Mesos, and Yarn. So all of those are supported out of the box today. We also support local for development mode only. But so what is Spring Cloud DataFlow? DataFlow is about orchestration. So we've been looking at these microservices. And let's be honest, as developers, you're going to spend 80% of your time, 90% of your time, writing, debugging, testing those individual boot applications. That's where the bulk of your work is going to be. But the orchestration piece is what DataFlow handles. The orchestration piece is the assembling of those microservices into meaningful applications. You can interact with it in a number of different ways. There's an interactive shell, which we'll look at. There's a web UI, which we'll look at. And both of those sit on top of a set of RESTful endpoints that you can call directly if you want. This is actual code in Spring Cloud DataFlow. If you've never seen Spring XD, this might be new to you. This is saying, take the HTTP module, here, open up a port, listen to HTTP traffic. Anything you get, send over the wire to a filter module. Anything that gets, then passes the filter, obviously. Send that over the wire and write it out to HDFS. Now, how does this map to those microservices and the binders in Spring Cloud Stream? The red lines are your binders. So in the previous example, that's a rabbit hop, and that's a rabbit hop. Does that make sense? Or Kafka or Jumpfire, insert whatever binder you're using there. But instead of actually defining what channels you need to run and keeping all that straight, DataFlow handles it for you. I type in HTTP pipe filter pipe HDFS. DataFlow says, OK, I'm going to create this channel, and I'm going to create that channel. it worries about that for you. With DataFlow, there are no installed containers. It's boot apps all the way down. So the server itself is a boot application. The shell is a boot application. Both of them you can build yourself using start.spring.io with a single annotation. @enable DataFlow server, @enable DataFlow shell. Create main methods with each one of those, and you will get either a DataFlow server or a DataFlow shell. And as we've already seen, all of the microservices themselves are boot apps as well. So in case you can't tell, we're kind of all in on boot. This is kind of a diagram of what a DataFlow environment might look like. So you've got the DataFlow server. Sitting below it is a data store, typically a database, doesn't have to be. We use that very minimally, specifically the task repository. We store stream definitions in there, as well as task definitions in there. That's really it. So it's not a very heavily used data store. The DataFlow server is going to run your individual microservices. Those are your boot applications. And then you interact with it, like I said, with the shell or the browser. I actually should have or via the REST API directly if you want. What we're about to look at in my demo is we're going to have 3 microservices. We're going to have a Twitter microservice that ingests the Twitter stream. We'll have a file sync that's going to write that Twitter stream to a local file. And then we're also going to have a field value counter, which we'll use to count hashtags that come through on that stream. Does that make sense? The way this will look like from an actually execution perspective is, like I said, the Twitter source will ingest the data. It'll write to the file, and there's actually going to be a wiretap that will send a copy of the data to the field value counter, which will actually do its analytics. Let's take a look. So I can kill this. All right, so I'll go ahead and I'll start off by starting up the DataFlow server. And just to prove I'm not lying, this is the DataFlow server code. This is the actual code that we're running. So I've got my boot application. This is the normal one we've already seen twice before. Here's my DataFlow configuration. I've got act configuration, enable DataFlow server. That's it. If Josh Long were here, he'd be live coding all this because of that. So with it started, this is the UI for Spring Cloud DataFlow. We've got apps. We've got runtime. This would show us running apps if there were any actually running right now. We have streams where we've got stream definitions, and we can also create a stream, which we'll look at in just a minute. We have tasks, which show me the task apps that are available, task definitions that are available, as well as if I've run any task executions, I can view the historical data there. Since batch jobs are a common use case, we also have a broken out tab for tasks, or for jobs, although every job within Spring Cloud DataFlow is run as a task. So, and we actually, if you run a job as a task, there's actually a link that allows you to click and go back and forth. We also have an analytics tab that we'll look at as well. So I want to run a stream. I want to run that Twitter pipe file stream. In order for me to do that, I need to register some applications. As we talked about before, all of these all these microservices are just Spring Boot applications. So I need to register them with DataFlow so it knows where to find those microservices. In this case, I'm going to use Maven coordinates. So I've already installed the microservices in my local Maven cache. And so I'm just going to specify a name and a URL for each one of the microservices I want it to run. So we have 3 total. Start off with Twitter. source. So I've got the name, the type, source, processor, sync, or task. This is a source. And then the Maven URL. So Maven : / group name : artifact ID : version. That's the Twitter one. So now I've got file. That's a sync. And then I've got my field value counter as the other one. Shoot.
What does the force checkbox do?
Force. If you've already deployed this,
Oh,
it'll override it. That's a sync. Okay. So these are my 3 applications that we're going to use. So Twitter is the source, file is one of the syncs, and field value counter is the other sync. So go ahead and click register. They're all registered now. So now if I go ahead and go over to streams, I've got this cool little UI that I can actually drag and drop to create a stream. So I'm going to go at Twitter, and I want to file, and connect. And for the record, if I check that checkbox, it would have connected them for me automatically. I want to configure the file one. I want to be specific on where I write my output to. So I want that to be in that directory. I could configure all this other stuff if I wanted to. The directory is the only one I really care about. So go ahead and click OK. And just to make sure there's nothing up my sleeve. Yeah.
Where's the metadata for that last screen you showed?
This?
How does it know to draw those fields and not some other sentences?
Excellent question. So there is for each one of these modules, there is a properties object. Basically, we do some analysis on the actual jar file.
Can you repeat the question?
Sorry, it was how do we know within this UI what these properties are that are configurable?
Thank you.
So that's that. Just I just want to call out there is no file sync file in here. That's the name of the file that we'll be creating in just a second. So I'm going to go ahead and create the stream. I need to give it a name. We'll call it CJUG tweets. And I'm actually going to deploy it. So go ahead and create. So go over definitions. It's deploying, which means it's actually launching the 2 other JVMs. So if we actually go ahead and go to, you can see that there's the Twitter source, and there's the file sync. So those Java processes are already running. You can see it's deployed. So if we go ahead and go over here, now we can see there's that file sync file that I've just mentioned. If we tail it, you can see there's all the Twitter data coming through. Does that make sense? So now let's go ahead and create a wiretap. The wiretap is going to create a copy of anything that goes over this pipe, so anything from Twitter to file, and send it to my field value counter. That will actually create, there we're going to count the hashtags that are coming through. And then we'll visualize it within this UI. So let's go back over to here. And actually, we'll go ahead and do this from the shell. So go back and grab the, where am I at? So this is the shell. So there's the DataFlow shell. If I can hit tab, and it'll give me basically everything I'm allowed to do. Even if I wanted to type this by hand, I won't. But stream create. It's not doing it for that one. But you can see it's gives me the various options for each module. But I'm not Josh Long, so I copy and paste. And what are we doing here? I've got stream create, name, that's not going to work because that's the wrong. I changed the name of the stream. That's going to change. So, sorry about that. So stream create name, cjug tweets count, definition, cjug tweets.twitter is how we define a tap. So that's saying, look in that stream, and after that module, insert the tap. And we're going to send that to the field value counter module, or app. The field, which takes a parameter field name. The field name we're looking for is actually JSON path to the hashtag. And we're going to store that as a field value counter called cjug tweets count tags. Go ahead and deploy that. So you can see all the same things that are available within the UI are also available via the shell. I can see the streams. I can see my list of apps, etc. So my tap is now deployed. So I can list my field value counters. There's the one that I just created. And for the record, this is live Twitter data, so I apologize in advance for anything that may be inappropriate. But you can see it's actually counting hashtags as they come across. And if we wanted to, we could also go over to this analytics tab. I've got field value counters, which is what we're using. I have this particular one. And I've selected the bubble chart. And so this is updating every 2 seconds. I can shrink this down so it fits. But as hashtags are coming in, this will update real time. Well, polling every 2 seconds. But this gives you an idea as to the API that's exposed that you could interact with on your own if you wanted. Does that make sense?
How does
Yeah.
this run across several machines?
How does it run across several machines?
Yeah, like you want to launch a task on a different machine. Is that possible to do?
Sure. So the question was, how do you do this across multiple machines? Like I mentioned before, it only works on Cloud Foundry, Kubernetes, Mesos, and Yarn. All of those we're delegating to the underlying infrastructure for the actual launching. So we use Mesos' API, we use Cloud Foundry's API to do all that. So where the actual application ends up running is really the underlying infrastructure's problem, not ours. We've actually created, so one large difference from Spring XD to this new solution is there's a lot of smaller projects that make up DataFlow. One of them is a deployer project. So there's the Spring Cloud deployers that is basically the implementation of how we interact with each one of those various frameworks. And if you wanted to write your own, we provide the interfaces and you could write your own for, pick whatever latest and greatest fabric you want to write one for. Does that make sense? Yeah.
Does this get into the mode of like service discovery then? Let's say I have a Mesos cluster or something and I needed to find where Kafka lives. Does it have to be hard-coded in, like the list of brokers up front as part of the application spec, or can you delegate that to something like a console or Mesos' own mechanisms?
No, you should be able to use service discovery with this. Okay. It'll require, it's not out of the box, it'll require configuring the client yourself.
Okay.
But like, for example, using Eureka with Spring Cloud stuff,
Yeah.
Just using the Eureka client in there will solve that same problem.
Are you checking types when you
does that come out the wash?
That's up to you. Which goes back to the whole testing earlier you were asked. So the question was, are we checking types between the different microservices? The answer is no, we're not. That goes back to your question about testing. The framework I mentioned, that Apress framework, which, like I said, I'm pretty sure is going to become Spring Cloud Contract. The idea is that it tests the contract. You define a contract and you validate against it. So if you're writing tests that are validating the contract and everybody's passing, in theory, those should work.
Is there any out-of-the-box support for serialization libraries as well? I know that like sending strings back and forth, but let's say that I've got a complex object and serializing the protobufs. Is that part of the framework as well? Or?
So Spring Cloud Stream does support some of that, like Cairo. Yeah. But we're also, one of the things that we're going to be looking at over the next year is schema maintenance is the wrong term, but managing schemas, making sure data can live longer. So because if you have a schema that's going from microservice to microservice, you want to be able to upgrade the microservices independently, which means you need to be able to manage schema differences between them. So that's something we're actually going to be looking at, is managing those types of things over the course of the next year. But in short, yes, from a flat out, if everybody plays nice, yes. Other questions? Yeah.
Do you see support for AWS coming up for design?
So do we see support for AWS coming out? Define AWS. So like Cloud Foundry will run on AWS, and we support Cloud Foundry. I don't know, can you run K8s or Mesos on AWS? You've got to be able to.
With a little bit of massaging, yes.
Yeah, so the thing is if you're thinking specifically EC2, deploying to EC2 is a bit of a different beast than any of the other ones we've mentioned. It is something we're aware of. We'd be more than willing to accept community contributions back for it. It's probably not going to be on the short-term roadmap, though, for raw EC2. Other questions, comments, concerns, thoughts?
Extra credit. So instead of pulling from Maven, could you like pull a Docker container or something like that?
Excellent question. The question was, can we use Docker instead of Maven? Yes, actually you can use Maven, Docker, or File System are the three currently supported. File System specifically, not only local, but HDFS as well. So if you're on Yarn. Let's see. Oops. But wait, there's more. Really not. I'm just going to go through all the features that are available in these tools that I'm not covering tonight. Specifically, task integration with streams and task integration with batch. I mentioned what those are, but like I said, I don't want to keep you guys here till 2 in the morning, so just be aware that those integrations exist. I talked about them, something to dig into later. Partition streams is another thing that I didn't talk about. The ability to have stateful components within a stream is obviously a very useful and necessary requirement, and we have that capability built in. It's just not something I've got time to talk about tonight. Scaling streams or tasks. Didn't get to it? Yeah, we do that. You can do module counts when you deploy a stream. So I can say HTTP pipe transformer with a module count of 5, pipe HDFS, and then I would get 1 HTTP, 5 what I say, transformers, module, the middle one, and one of the last ones. So we have that capability built in. The current state of all these projects. So Spring Cloud Stream is actually GA. It's 1.0.2 is the current release. They'll have a 1.1.0 M1, or yeah, 1.1.0 M1 by Spring 1, which Spring 1 platform is an awesome conference. It's the Spring's annual conference every year. It's in Vegas this year. Highly recommended. Come check it out. That's August 1st to the 4th. Spring Cloud Task. We just released RC1 this week with the expectation for us to go GA literally next week. And the same goes for Spring Cloud DataFlow. So we released the RC yesterday, and we're expected to go GA next week. Here are some useful links.
I'm coming from Turkey.
Okay.
Your subject is very interesting. I am an software architect for Stock Exchange Market of Istanbul.
Okay.
Securities.
Okay.
and we have relationship with NASDAQ also. And now we are using, have you ever heard about Camel? Apache Camel.
Oh yeah, yep.
Yeah, your application is very similar to Apache Camel, but there is a good point of your application is you can do unit testing, and you can also make lots of things configurable, as you mentioned before, and also the integration part is very, very nice. And I'm thinking about, for example, we are now giving some information to other, how to say, other security dealers, like brokerage houses, something like that. And we are giving that information by files.
Okay,
You know,
I'm sorry.
And we are using Camel to distribute the files.
Okay.
The Camel is listening to the directory and distributing the files, something like that. And as you mentioned, JUnit testing, and also the advantages of integrating the streams and other
the tasks
streams and other tasks, etc. It will be very useful for us to use your solution. I think this cloud.
Good to hear.
And when I turn back to Turkey, I will be in Turkey in 14th of July.
Okay.
I want to get in touch with you and make some demos about the solution. And we can, this is open source, isn't it?
Yes, all this is open source.
That's great.
Yes, yeah.
And,
how about grab me afterwards?
We can make a production solution, something like that. And it will also be a reference to NASDAQ.
Cool. Grab me afterwards.
Yeah. Also, just last month we actually had a presentation on Camel and Spring integration kind of side by side. So if you check out our videos, another thing to kind of.
We are now using Camel for listening GMS, Java Listening Service, and IBM MQ integration. It's very nice. But the good thing about this solution is integration of integration of tasks and
streams.
Streams. It's very great. And also the JUnit testing. On Camel, it's not easy to make JUnit testing.
Other questions?
We can talk later.
What do you think about Camel if you compare the solution?
Let's talk after.
So, what would you say are some of the areas in the framework that are still kind of rough around the edges, other than the stuff that hasn't GA'd? Are there things that are less tested or haven't been like pushed to production yet by client deployment?
So basically, where are the gotchas?
Yes.
Task support on some of the runtimes isn't as well as far along as I'd like it to be. That's an area that's still a little rough. Not that it's not coming, but it's probably needs another month after this. Trying to think what else. That's probably the main piece. And even that, it's the tasks issues that I'm thinking of specifically. It's the deployers. It's nothing that I showed today. It's all. I mean, go ahead and look at our commit logs for Spring Cloud Task. There's been barely any real like heavy lifting in weeks because we're done. Yeah, it's probably the main piece. So the question was: are dependencies a bigger issue than than this itself? And with start.spring.io, if you're unfamiliar with that, that's the easy way to create Spring applications. So basically, you tell us what within the Spring portfolio you want. We're going to drop in the dependencies for you. So
just for the stuff that depending on what you're showing, for these different microservices and trying to either work with messaging, underlying. Do you guys have ways to like log or do like wiretaps to see? And I saw some of that a lot.
Yeah, so the question was is what kind of logging and whatnot can you do to debug this kind of stuff? Is that fair?
Yeah.
So there's a couple different options. Number one, just cranking up the debug logging in these will give you just about everything you could possibly want with regards to the communication with the middleware. Just literally changing the logging level to debug on the stream stuff and the integration stuff gives you literally a fire hose of extra information. If you wanted to get more fancy, you could incorporate one of the tracing solutions in Spring. So Sleuth or Zipkin, either one of those. Then you get distributed tracing, and that's a whole nother talk. Other questions, comments, concerns?
What sort of applications this microservices will mostly fit in?
In this case, what I talked about tonight, any data application. So anything from moving files around in small batch processes to big data ingestion and IoT stuff. We have customers right now that are using this, specifically Comcast, HSBC, and who was the other one? Who was the other one? There's another one, I don't remember what it was. But also the underlying concept of this is also what's underneath Spring XD, the idea of these modules communicating via middleware. And we have got customers in production in just about every industrial vertical you can think of. Everything from industrial IoT, ingesting data off of jet engines, all the way to media, tracking ad views on mobile apps, to banking and financial. So this underlying concept is something that we have in production all over the place. Yeah.
You mentioned moving files. How does the if you're running multiple nodes, does it handle file extension?
So the question was, how do we handle multiple nodes with files, basically? In short, there's some gymnastics you may need to do. It's one of the penalties of files. You physically have to be there, or you have to be able to share the drive somehow, NAS or whatever. That's all I have. So unless there are any other questions, I'll still be around.
When can we expect Cloud Task to be GA?
Next week.
All right.
Yeah, Spring Cloud Task will be GA next week.
I'm trying. I do what I can.
Cool. Thank you, everybody.